Hi, we're going to walk through the Skydiver problem. I wanted to just talk you through it, even though I provided the key for you, because sometimes it's easier to figure it out when you know where things are coming from. So at the top, we're talking about a skydiver who is jumping out and doesn't take the parachute and open it right away. So we're going to take a look at what that looks like. And then eventually we're going to look at what happens to the forces on the skydiver after the parachute is open. So to begin our thinking about it, let's just think about something that is tossed into the air or shot into the air like a cannon, like we're seeing here. We have given you a new equation here. Force of air is kV squared. And this is to talk specifically about air drag on something that is falling so that you can figure out how fast it's going. So that's a new equation for this. The constant K depends on how big the person is, the size, the shape. And so we're going to give you some values for this constant along the way to represent the fictional person that's falling through the air. And that changes too when the parachute opens. So it very much depends on the situation. Something you want to keep in mind here is that the force of air drag acts in a direction opposite to the velocity of the skydiver. So air drag and velocity are in opposite directions always when somebody is falling. Okay, let's start by taking a look at the units. So what are the metric units for force, velocity, and then this constant? So force, nothing changes, it's newtons. Velocity, nothing changes, meters per second. For this constant K, you can see that is a crazy unit. And if you're interested where that comes from, I've derived it for you over here on the side, and you can take a look at that on your own time. So let's go on to number 2. If you are shot straight up out of a cannon, air drag will point which way? So imagine we've got this cannonball and it's being shot this way. If the cannonball is moving up, then the force of air will be moving against it. So it's going to be moving in the opposite direction. So I have gone ahead and I have drawn a free body diagram here. The force of air is down. And so my free body diagram, I've got the little dot, I draw the force of air down. On your way down, that changes. If you are going down, the force of air is up. So air and you, as the diver, are always going to be in opposite directions. Okay, so those are going to be opposite. So make sure as you make your way through this document, 3-page document, that you keep that in mind. Whichever way your velocity is pointing, if it's positive or negative, your air drag is going to be opposite to that. Or if you're having a hard time figuring out, should my velocity be positive or negative, think about the air drag, and then it'll be the opposite of that. So that's a good way to think about it. All right, so number 4. We've got a 75 kilogram skydiver. So this is the skydiver's mass. So just maybe label that so that you've got it in your brain. That mass, of course, is always kilograms. Okay, so this is the mass, not the weight. This is the mass of the skydiver. So part A. What is the force of gravity on this 75 kilogram person? This is often called weight. So I've gone ahead and I've solved for the skydiver's weight. You take mass times gravity, and gravity, you want to make sure that you've got that negative. And so your weight of the skydiver also will then be negative. We get a negative 735 newtons. And what's the initial downward acceleration? It's gravity. Okay, then for 5, after he has fallen for a few seconds, the air drag has built up to 380 newtons. What is the direction of the air drag? So if you are falling down and your velocity is in the downward direction, then air is going to be up. So I've answered that one, up. And then it says, what's the net force acting on him? And we went ahead and gave you the answer to make sure you could check and see if you did it right. And so I've drawn a little free body diagram over here. I've got the weight of the skydiver. This does not change for this entire problem. The skydiver's weight is the skydiver's weight. He's not eating a significant amount of meals or shedding any clothing or anything like that. So the weight of this skydiver will not change. This stays the same. And then the information we gave you is that the force of air is 380 newtons up. So to find the net force, you're going to just add those two together. So we have a negative 735 plus 380, and we get a negative 355 newtons. And then for C, what is the size and direction of his acceleration now? So now we can use F equals ma to go ahead and calculate acceleration of the skydiver. This is all before the parachute opens. And so you see I've got the solution there. So I take F net divided by m. I use the 355 that we just calculated, and I get a negative 4.73 meters per second squared. And the negative means I'm moving down. It's in the downward direction. Moving on. Number 6, as he falls, his speed increases. Makes sense, right? You're falling, it's getting faster and faster. What happens to the magnitude of the air drag? Magnitude just means size. Increase, decrease, stay the same is typically the answer for that. So the air drag is going to increase the faster you go. At some point, the speed can't increase anymore. Why not use complete sentences? So eventually, the force due to air is going to equal the weight. So eventually, you can't fall any faster. We call this terminal velocity. Okay, and the net force will just keep decreasing until the net force is 0 and you're moving at a constant speed. The reason is because the more you push down in the air, the more the air pushes up on you. And so those two things are going to just equal out. Number 8, at the point he can't increase his speed, he's now falling at terminal velocity, which I've shown over here. Force of air is equal to force due to gravity. I went ahead and drew the free body diagram there. And so the net force is 0. And what is the size of force of air drag acting on him? Positive 735. If those two things are equal, then whatever the skydiver's weight is, that is going to be the force of air drag once you've reached terminal velocity. Those two things need to be equal. Moving on. Number 9. If the force of air equals kV squared, that's the new equation we gave you. That's what takes somebody that's falling through the air, and you can calculate velocity using this equation. And here we've just given you a K value that we've provided, a common K value for just like an average person falling through the air. What is the terminal velocity? So I went ahead and showed you how to solve this. We're going to put our 3 variables here, force of air, K and V. I'm going to fill in what I know, and then I'm going to solve for the missing variable. You need to be careful because we have some squared here, which means you've got some square roots that need to happen. And when you do all of that, you get a velocity of 49.5 meters per second. So you can check and see if you were able to get through that math okay. So then, moving down to 10, excuse me, it says now let's say the K value goes up because we've opened the parachute. Once the parachute is open, there's going to, it's like hitting the brakes in a car, right? So this K value has now gone up. And so there's more air drag. Right, so more K value means more air drag. And then we're going to go ahead and use the speed from number 9. So it says, what is the force due to air just as the chute is fully opened? So I'm going to go ahead and solve just like I did before. I've got my force of air, I've got my K value and my velocity. Went ahead and did the math, and I get this giant force of air now that the parachute is open. And then again, to find the net force on the skydiver, same thing. The weight of the skydiver does not change, right? So you keep the same weight, you put in the new force of air now that the parachute is open, and then you can solve for your net force just by adding those two together. One is negative, one is positive. And you end up with this giant net force of 48,760 newtons. Let's go ahead and solve for acceleration again, like we just did, but now we're using the new net force and solving for acceleration. This is a huge number, which is why we wrote the word ouch over here in the corner, because that would be something. You would be feeling that quite a bit. And it says it's not reasonable. And the good thing is the parachute doesn't open instantaneously. It sort of unfurls. So it's not like someone slamming on the brakes. It's like someone just gently pressing the brakes. So that it doesn't, like, really hurt you when it opens. So now the parachute is open. For 11 and 12, it says with the parachute open, what happens to the speed of the skydiver? It decreases because the parachute is like brakes, right? The parachute is the brake. And then what happens to the acceleration? It also decreases. So the F net decreases because the force of air decreases, which means also the acceleration decreases. All of it goes down. But the velocity is still in the downward direction. You're not going up. So somewhere down here, write down velocity is still negative or down, right? We're still moving. We didn't stop completely. We're moving at a constant speed, and it's still in the downward direction. So that should help you navigate this problem. And you can go ahead and calculate the new value of the terminal velocity and then double check the key and see how you did.